Welcome back to Building Construction Buddies, where we break down all things construction related with a sprinkle of buzzworthy puns along the way. Today, we're digging deep, literally, into a topic that forms the foundation of every structure you see around you. We're talking about soil types and how they affect your construction projects. Understanding soil is fundamental to laying a strong foundation, and in today's video, we're going to cover 5 major soil types: clay, sandy, silty, loamy, and peat soils. We'll explore their properties, how they impact foundation design, and give you the pro tips you need to get your foundation right. Let's dig in. First up, we have clay soil. If you've ever worked with clay, you know it can be tricky. Clay is made up of fine particles that are tightly packed, giving it high plasticity and low permeability. This means clay holds onto water like a sponge, which makes it prone to swelling when wet and shrinking when dry. According to the International Building Code Section 1803, one of the major risks with clay soils is their potential to cause foundation movement. As the soil expands and contracts, it can lead to cracks and even differential settlement in the foundation. Now, the pros of clay soil: it's highly cohesive, which can provide stability once compacted. However, the cons far outweigh the benefits for most construction sites. The expansive nature of clay soils can lead to long-term issues if not properly mitigated. To counteract the expansion and contraction of clay soil, it's critical to use deep foundations like piles or caissons that bypass the unstable upper layers of soil. You can also implement proper drainage systems to reduce water retention around the foundation. Next, let's talk about sandy soil. Unlike clay, sandy soil has coarse particles with low cohesion, meaning it doesn't hold together as well. But here's the good news: high drainage capacity. Sandy soil allows water to flow through easily, which reduces the risk of water-related foundation issues. Because of this, sandy soil is often considered a good option for foundation support as long as it's properly compacted. Without compaction, sandy soil is prone to settling over time, which can cause problems for the structure. The pros of sandy soil are its stability after compaction and high drainage. On the con side, you may need additional effort for proper soil stabilization. For sandy soils, it's essential to use compaction techniques such as vibratory rollers or dynamic compaction methods to increase the soil's load-bearing capacity. In areas with very loose sand, consider adding geotextiles for extra stabilization. Now let's get a little muddy. Silty soil is next. Silty soil has fine particles, similar to clay, but it's less cohesive. This means that while it retains moisture, it's prone to becoming unstable when wet. Silty soil is highly susceptible to erosion, especially when water is involved. Foundations built on silty soil can suffer from differential settlement or washout, where soil beneath the foundation gets displaced. In terms of pros, silty soil can offer decent moisture retention, which might be useful for certain landscaping or agricultural applications. However, the cons make it a risky choice for foundation work. The lack of stability when wet can cause significant structural problems over time. When dealing with silty soil, make sure you incorporate adequate drainage systems to manage water flow and avoid saturation. Also, you may want to mix the silt with stabilizing materials like gravel or use soil cement to improve its load-bearing capacity. The golden child of soil types, loamy soil. This soil is a balanced mix of sand, silt, and clay, making it ideal for construction. It has the drainage of sand, the moisture retention of silt, and just enough cohesion from clay to keep things stable. Loamy soil is widely regarded as the best soil type for foundation work. It's well-draining but retains enough moisture to prevent issues like shrinking or swelling. This balance makes it a preferred choice for construction projects, from residential homes to commercial buildings. The pros of loamy soil are obvious. It's versatile, stable, and offers the right balance of properties needed for a solid foundation. The cons are minimal, but in areas with heavy rainfall, you might need additional drainage just to ensure the soil doesn't retain too much moisture. If you're lucky enough to build on loamy soil, make sure you take advantage of its natural properties by using shallow foundations like spread footings or strip footings. Just ensure that the site is graded properly to avoid excess water pooling around the foundation. And now we get to the troublemaker, peat soil. Peat soil is rich in organic material and is highly compressible, which means it can be a nightmare for construction. Low bearing capacity and high levels of water retention make this soil type extremely unstable. The biggest issue with peat soil is settlement. As organic matter breaks down, the soil compresses, leading to foundation subsidence. It's not uncommon for structures on peat soil to suffer from significant movement over time unless specialized techniques are used. The pros of peat soil are pretty slim when it comes to construction. It might be good for agriculture or environmental restoration, but for foundations, it's highly problematic. The cons include low bearing capacity, high compressibility, and a tendency to trap moisture, all of which lead to serious structural issues. If you must build on peat soil, consider using deep foundation systems like piles that transfer the load to more stable soil or bedrock beneath. Additionally, preloading the soil with temporary loads can help compress the peat before construction starts, reducing long-term settlement. To sum it up, the type of soil you're building on has a massive impact on your foundation design. Whether you're dealing with expansive clay, well-drained sand, or troublesome peat, understanding the properties of the soil can save you from a world of trouble down the road. And remember, whether you're a DIY enthusiast or a construction pro, always consult with a geotechnical engineer and refer to the building codes, like the International Building Code, IBC, or the British Standard BS 8004, which provide guidelines for safe foundation design based on soil conditions. Thanks for tuning in to Building Construction Buddies. Be sure to hit that subscribe button and drop us a comment below on what soil types you've encountered in your projects. Until next time, keep buzzing!